Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to Technogenier. In this video, I will discuss about the wind energy, and specifically we will discuss how wind energy is converted into electricity. In this lecture, I will discuss what are the major parts of the wind turbine, how it works, its historical background, and what are the different types of the wind turbine. So these are the basic content. Initially, I will discuss about the basic concept of wind and how wind is generated, and the historical development of the wind energy. Then I will discuss the basic component of the wind turbine, and finally, I will discuss different types of the wind turbine. So first of all, wind energy. Wind is air in motion, and it drives energy from solar radiation. As you know that wind is basically the movement of the air, and specifically when the sunlight fall at the surface of the earth, then basically there are two types of surface. One is the ocean area where there is water, and one is the surface land area. So in the day the temperature at the land area is high compared to the temperature at the water area. So the air from the cool area is moves from the cool side to the hot side. So from the ocean, the air moves toward the land. So this motion of the air is known as wind, and when it hits to the wind turbine start rotating. While in the night, the direction of the wind is reversed, because the land surface cool much faster than the water bodies. So the air flow direction would be the from the land to the sea. So historically, if you see that in 4000 BC, the Egyptian uses the wind turbine to crush for the direction of the boats, or for the movement of the boat. And after in 10th century, windmills are used to grind the grains in Iran and Afghanistan and different countries. So wind energy has a long historical background, but for the sake of generating electricity from the wind turbine, it's start at 1891, when the first wind turbine is created in the Denmark. And after that, in 1929, a 20-meter height wind turbine is created by the French engineer. And in 1950, Danish electrical company tested a 200 kilowatt wind turbine with a synchronous generator. After that, in 1990, Denmark, Germany, and China, and even the Spain uses the wind turbine to produce electricity, and the maximum rating to use the wind turbine to produce electricity is almost 1 or 1.5 megawatt. Secondly, if you know that the major electricity generation, or the companies which produces the wind related technologies, are especially Danish companies, and almost 27% of the wind energy technology share is to the Denmark. And in the Denmark, almost 20% of the electricity is generated from the wind turbine. So if we see the worldwide potential of the wind turbine, it is almost 72 terawatt. While if you see the statistics of the wind energy generation in the whole world, it is approximately equal to 650 gigawatt in the year 2019. So the basic concept of the wind turbine is that the wind energy is basically the kinetic energy, and this kinetic energy is converted into mechanical energy, and the wind turbine start rotating, and that mechanical energy is converted into electrical energy. So all the wind turbines, from the smallest to the largest, work at the same principle. So the major components in the wind turbine is basically the rotor blade that convert the wind energy into rotational shaft. Then we have the nacelle. Nacelle is basically the enclosed container in which there are gearbox, and then the generator is enclosed in the nacelle. And then when the wind turbine or the blades rotate, it start rotating the generator, and then from the generator electricity is produced. So this is the basic composition or the basic component of the wind turbine. If you see If you see this part, this is basically the hub where the blades are connected. This is the center part of the wind turbine, and from that there are multiple blades connected. Normally there are 3 blades wind turbine or 5 blade wind turbine. So from the hub, there is a enclosed body which is called a nacelle, and inside the nacelle there is a gearbox and then the generator. Usually the turbine rotated very small, low RPM, usually in 20 to 50 RPM, and from that RPM there is a gearbox which convert this RPM and convert at a multiple ratio. That means almost convert the 30 rpm to almost 1500 rpm, and that 1500 rpm rotation shaft is connected to the generator, and the generator start rotating and produce electricity. Normally the basic formula to produce electricity, if we have 50 hertz, then it is the formula speed n is equal to 120 f over p. So if we need to produce the frequency at 50 hertz, then the speed, if it is 50 hertz and the number of poles is 4 poles, then the speed would be 1500 rpm. Usually the blade speed is 330 rpm. So in order to attain the 1500 rpm, the gear ratio is almost 1:50. So the 30 rpm will be converted into 1500 rpm. Then there is a tower. This is simple a mechanical tower which support the wind turbine, and from that tower there is a control mechanism, and an electronic control is attached, which electronic control will control the gear ratio or the gearbox and then the output. Then there is a special concrete base which supports the whole tower, and from the control connection it goes to the transformer. Transformer is used to step up the output of the wind turbine to the high voltage AC system. So this is the whole wind turbine component. So one by one I will discuss the basic concept of each component. So first, the nacelle. Nacelle is used as a weatherproof streamlined enclosure for a housing shaft. It contains a generator, a controller and the rotary brakes. So the second thing is rotary blades. Rotary blades are often made up of fiberglass reinforced with polyester, and then typically rotary blade rotate at approximately 10 to 30 rpm, either at a constant speed or typically a varying speed. Then we have the gearbox. Gearbox is basically to increase the rotational speed of the rotor to fit it to the generator. So normally the gear ratio is 1:50 or more than 50. Then we have the brake. There is a certain speed which a rotary blade can support. After that, if the speed increase to that area, then there is a chance to break the rotary blade. So in order to control the speed or reduce to protect the protect the blade to for the damage, then we use special kind of rotary blade braking system which apply the brakes and protect the whole system. इसको इस तरह समझ लें कि हमारा जो विंड एनर्जी है वो मैकेनिकल मोशन, जो रोटर ब्लेड्स हैं वो रोटेट करती है और मैकेनिकल मोशन से इलेक्ट्रिकल एनर्जी क्रिएट होती है, लेकिन उन ब्लेड्स की एक लिमिट होती है. एक सर्टन स्पीड से ज़्यादा अगर वो ब्लेड्स रोटेट करने लग पड़े तो वो ब्रेक हो जाती. नॉर्मल ग्राफ अगर मैं ड्रॉ करूं तो विंड टर्बाइन का ग्राफ कुछ इधर से ऐसे बनता है और एक सर्टन पॉइंट के बाद ये सीड कर जाता है, और ये इस एक्सिस पे देखें तो ये यहाँ पे ये स्पीड आती है जिसको हम एन कहते हैं. इस एक्सिस पे ये एन आ रहा है. अब अगर देखो तो कुछ एक पॉइंट ऐसा आता है जिधर कोई विंड टर्बाइन रोटेशन, जितनी मर्जी स्पीड हो लेकिन विंड टर्बाइन की कोई रोटेशन नहीं. फिर एक पॉइंट है यहाँ से लेके यहाँ तक, लेट्स सपोज मैं कहता हूँ ये 5 आरपीएम से लेके 10 आरपीएम तक है, जिधर जो है ग्रेजुअली इंक्रीज कर रही है, ट्रांजिशन फेज है जिसके अंदर हमें स्पेशल कंट्रोल मैकेनिज्म लगाना पड़ता है इसको सस्टेन करने के लिए. उसके बाद एक टाइम यहाँ पे अगर आप देखें तो ये इसको कहते हैं स्टेडी स्टेट स्टेट रीजन, ये नॉर्मली 10 to 25 या 10 to 30 आरपीएम तक जाता है, ताकि इस पॉइंट पे जितनी मर्जी आरपीएम हो ये स्टेडी स्टेट आउटपुट पे 50 हर्ट्ज हमें आउटपुट पे दे देते हैं। उसके बाद अगर स्पीड एक्सीड करती है तो यहाँ पे चांसेस हैं कि हमारी ब्लेड जो है डैमेज हो जाए, टूट जाए, तो यहाँ पे हम ब्रेक्स लगा देते हैं। ये यहाँ भी ये ब्रेक का रीजन आ जाता है। तो अगर आप देखो तो ये रीजन और एक ये रीजन, इन दोनों रीजन से कोई विंड एनर्जी, कोई इलेक्ट्रिसिटी नहीं प्रोड्यूस करते। उसके अलावा इस रीजन में और इस रीजन में विंड टर्बाइन इलेक्ट्रिसिटी प्रोड्यूस करती है, ठीक है। अच्छा, फिर उसके बाद आता है हमारे पास कंट्रोलर। कंट्रोलर का मेजर मकसद क्या होता है कि ये जो है स्टार्टिंग, स्टॉपिंग, ब्लेड्स की स्पीड, इन सारी चीज़ों को कंट्रोल करता है। अगर आप ये सेंटेंस देखो, सेट ऑफ इलेक्ट्रिकल कंपोनेंट दैट कंट्रोल द स्टीयरिंग, starting, the stopping and the turbine blade speed, typically in the constant wind speed model. The controller start up the turbine at the wind speed around 8 to 14 miles per hour and stop the machine at 55 miles per hour to avoid the damage. तो ये वो वाला रीजन है जिसके बाद वो कंट्रोलर इस स्पीड को कंट्रोल करने ब्रेक्स लगा देता है, और ब्रेक से बाद जो है ये फिर रोटेट नहीं करता। फिर आ जाता है जनरेटर। जनरेटर का स्पेसिफिकली मकसद वही होता है कि टरबाइन के साथ अटैच होता है। अब टरबाइन जब रोटेट करती है तो इसका मकसद होता है 50 हर्ट्ज या 60 हर्ट्ज इसने प्रोड्यूस करने हैं, तो वो उसके अकॉर्डिंगली इलेक्ट्रिसिटी प्रोड्यूस करता है। तो नॉर्मली जनरेटर का मकसद सिर्फ क्या है कि इसके अंदर इसके अंदर वो कॉइल होती है, और कॉइल के इर्द गिर्द जो है मैग्नेटिक फील्ड क्रिएट होती है। जब वो कॉइल मैग्नेटिक फील्ड के अंदर रोटेट करती है तो वो इलेक्ट्रिसिटी प्रोड्यूस करती है। तो इसके अंदर बेसिकली इंडक्शन एंड परमानेंट मैग्नेट जनरेटर लगा होता है जो बेसिकली रोटेशन कर होता है। हब का मेजर मकसद क्या होता है, ये बेसिकली सेंटर ऑफ द ब्लेड लगी होती है और ये कनेक्टिविटी प्रोवाइड करती है सिस्टम को अटैचमेंट करने के लिए ताकि ये रोटेट करे। फिर प्रोपेलर्स आ जाते हैं, ये टरबाइन शाफ्ट्स के साथ लगे होते हैं जो हब और ब्लेड्स को रोटेट करते हैं, सही है। फिर उसके बाद यॉ मैकेनिज्म होता है। अगर आप देखो तो विंड टरबाइन के नीचे एक मैकेनिज्म लगा होता है जो विंड टरबाइन को सपोर्ट कर रहा होता है कि जिस साइड पे एयर आ रही होती है तो जो उसका फेस होता है उसके अकॉर्डिंगली एडजस्ट कर रहा होता है, जिस साइड पे एयर है तो उसका फेस उसके अकॉर्डिंगली एडजस्ट करने का होता है। अगर आप देखो तो यॉ मैकेनिज्म इज कनेक्टेड टू अ सेंसर, स्पेसिफिकली इट इज एनेमोमीटर और विंड वेन दैट मॉनिटर द विंड डायरेक्शन, टर्निंग द टावर हेड and lining up the blade with the wind. A yaw drive is used to orient the nacelle and the rotor using the yaw motor or the hydraulic mechanism. A yaw motor is used to move the nacelle with its component. Finally, we have the tower. Tower is used to raise the turbine and hold the tower blade at the nacelle. So turbine tower, the tubular with the height approximately equal to the rotor diameter. Minimum height is approximately 26 meter to avoid the turbulence or the air fluctuation. The electricity produced by the generator comes down through cables inside the tower and passes through the transformer into electricity network. Finally, the base. Base is the large turbines are built on a concrete base for the foundation, and then the pitch control. It is used on the electric motor or the hydraulic mechanism. It used to turn the blades to maximize the power capture of the turbine or to reduce the rotor rotational speed in the highway. Then we have the brakes. It is used to stop the rotor for maintenance, and some advanced turbines are hydraulic brakes for the cut in and the cut out wind speed when the turbine power output is either too low or too high. We have low speed shaft. The low speed shaft are designed to transfer mechanical power of the rotor at a speed of 30 to 60 rpm to the gearbox, and then we have the high speed shaft used for the mechanical coupling of the gearbox and the rotor to the electrical generator. So if you see this diagram, then you will understand that the low speed shaft is attached with the blade while the high speed shaft is attached with the generator. Now we have the gearbox. The mechanism of the gearbox is to step up the gear ratio approximately from 1200 to 1600 rpm. We have the wind controller used to regulate to control the turbine, electrical and mechanical operation. Then we have an anemometer. Anemometer is a device which is used to measure the speed of the wind, and weather vane is used to measure the direction of the wind. So this is the wind turbine. If you see, this is the rotor hub, then we have the blade, then we have low speed shaft, then we have the gearbox, and we have high speed shaft, and then we have the generator. And all these things are mounted on the tower. There are two types of wind turbines. One is horizontal axis wind turbine, which you already seen that this axis is parallel with this axis, so it is called the horizontal axis wind turbine. There are two types of horizontal axis wind turbine. One is upwind, and the second one is downwind. For the upwind, the wind direction is toward the blade, and from the blade it goes out. While the downwind means the wind direction is from the back side of the blade toward the going toward the blade. So these two types are commonly used in the horizontal axis wind turbine. The second type is vertical axis wind turbine. So the major axis of rotation is basically perpendicular to the surface, so it is along with the direction of the tower. So there are different structures of vertical axis wind turbine. One is like this one, second one is this one, and third one is this one. They are commonly used in different kind of topology. Where the speed is low, then we prefer to have horizontal axis wind turbine, and when the speed is high, we prefer to have vertical axis wind turbine. Thank you, Jazakallah. Hopefully, you understand the basic concept of the wind energy. If you have any issues or problem, you can ask in the comment section. We will try to resolve it. Thank you. Allah Hafiz.